I've now seen 3 separate flat earthers make this mistake, and I guess I shouldn't be surprised because I also once had a teacher in college get it wrong, in a course on computer animation of all things. We know things appear smaller when they're farther away, but there's more to it. This happens because the rays of light we see must converge to reach our vantage point. Tracing them backwards, we would say the rays of our vision diverge. As previously mentioned, an object's apparent size relates to the inverse tangent of its distance. This means the farther away it is, the less the distance matters in how big it looks. If you zoom with a camera lens or look through a telescope, this is fundamentally different from traveling closer to your subject. You're taking a smaller subsample from your celestial sphere, so the rays of your vision will be closer to parallel, or less divergent, and size relationships at a comfortable distance will appear more uniform, like in an orthographic drawing. Anyone acquainted with techniques for framing a film or photograph will know this, and the effect is often exploited in cinema with a dolly zoom. This is a disorienting type of shot, with many famous examples. Rob Skiba was the aforementioned flat earther who speculated about atmospheric magnification. He claims to show an example of such magnification by comparing size relationships between 2 images of Willis Tower in Chicago. But it's painfully obvious these images show radically different distances to the subject, and therefore different size relationships. He is correct that the tower is magnified, but by his software and the telephoto lens on his camera, not the atmosphere.